Find the answers to questions you may or may not have asked yourself. Here at Kaleidocytes, Conversations on Cognitive Science.
In our focus month on the topic attention, we have today an expert on the attention when it comes to reading, and for that we like to welcome Eirini Kalogeropoulou. I hope I didn't completely butcher that name.
No, it's fine.
Okay, great.
And as always, we would like to play our short welcome game in the beginning. So I'm going to give you 5 sentence beginnings and would ask you to spontaneously finish those sentences.
Okay. Perfect.
And the first sentence is, as a kid, I always wanted to be.
Oh, wow. That takes me back. As a kid, I think I always wanted to be a ballet teacher.
Ballet teacher?
Yeah. I used to dance a lot from 5 years old till high school. But unfortunately, I had an accident and I couldn't continue. But it was my dream as a child, yeah.
Why did you want to be a teacher, not a ballet dancer?
I was very triggered how I can teach because, when you're a ballet dancer, you can dance till a certain age, like around 30. But a teacher continues. So I saw a potential there, and I really loved kids, and I preferred that.
It sounds like a really well thought decision, not just wanting to do the dancing, but actually wanting to be able to do it longer.
Yeah, exactly.
The second sentence is, if I was an emoji, I would be.
Oh, wow. I think the thinking one, like the one who is thinking, because I always think of something. Probably that emoji is me. With more hair, though, because...
True, it's always one of the classic ones without hair.
Yeah. But definitely the thinking emoji. I think a lot of things during the day. Sometimes I dream a lot, so definitely that one.
The third sentence is, my favorite thing to do on a day off is?
Now that I am back home in Greece, I definitely want to go to the beach. So if I have time, I definitely want to go there with my book, a nice coffee or a drink, and just relax there. Yeah, listen to the sea.
Are you living close or far away from the sea?
I live close. So
nice.
In around like 10 minutes by car, I am at the sea. Yeah.
That sounds pretty awesome.
Yeah, it is.
Right now, I'm most fascinated by.
Wow, nice. I don't know. Maybe recently I was fascinated by how people can see a potential in the future, like the hope that people have for things. I think that's the most fascinating thing ever, because I don't know, at least for me, it gives me passion to work, and I try to put it in my life, hope and a vision for the things that I do. So I'm fascinated by people who have that. Yeah.
That's a really nice answer. It just sounds so beautiful to say. I'm most fascinated by the hope people have about things and their lives.
Yeah.
I think it's also a really philosophical answer.
Yeah, kind of. Yeah. I think nowadays it's really important to have that and to look for that if you don't have it in your life.
Yeah, definitely.
Yeah.
And our last sentence is, I know it's time to call it a day when
I'm hungry. For sure. I think when my stomach starts making noises, it's time for me to say, okay, it's time for you to say, okay, that's it. Go do your thing. Yeah, definitely.
So
yeah.
for you, dinner time is the cutoff time of the day.
Yes, the best time ever.
Thank you so much for your answers. And I would like to know who you are, where you are, what you're doing right now, and how you came to what you're doing right now. So where did you start your scientific journey? What fascinated you most? And how did you become the person you are in your scientific field at the moment?
Yeah. So basically, I started my bachelor in Athens in Metropolitan College with a collaboration with the University of East London in the UK. My bachelor was in early childhood studies. So from the beginning, I had a strong interest in learning and how children develop their cognitive abilities. So as part of my empirical bachelor thesis, I was involved in a research project on inattentional blindness phenomenon. And we called the project The Invisible Dancer. So the aim of the study was to investigate the developmental differences in attentional blindness in younger children. So my responsibility was to create a video based on the paradigm by Simons and Chambers in 1999. It's a very well-known experiment with a guy dressed up as a gorilla passing up between some players that they play ball with each other. So I recruited participants from different primary schools, and I was in close collaboration with the parents that gave me the consent to their children. So we created a video from scratch because we couldn't use the video from the previous research. And we discovered high inattentional blindness rates compared to adult participants from previous research, which suggests that preschoolers experience great difficulty in perceiving unexpected objects in their environment. So it was also a positive correlation between AIDS and the phenomenon of inattentional blindness, and suggests that the phenomenon could be used as a useful tool to study the developmental aspects of selective attention and awareness in early childhood. So yeah, that
Could you maybe super quickly just say what attentional blindness is for our listeners?
Oh, yes, of course. So inattentional blindness is a phenomenon that describes that when you watch something, you might lose some information at some point. So if I tell you to count something, let's assume that we are in a basketball game, and I tell the person, okay, count how many passes the red team does with one another. And I basically tell them to focus their attention on one task. At the same time, a lot of things might have happened in the environment, but the inattentional blindness is about something that is striking. In my research, it was like a person that passes through the players. So it's something that we assume that, oh yes, of course I can see that. It's a person right in front of me. But unfortunately, we don't.
And I think in the original study you've just mentioned was a gorilla or person dressed up as a gorilla, and even there people don't notice that there's a gorilla running around.
Yeah. That's really interesting. And it fascinated me back then. I did this research in 2019, and it hadn't been researched in toddlers, in 4 to 5 year olds back then. And of course, we couldn't use the first video with a gorilla because it's something that might scare also the child. Mm-hmm. So we thought that we might change that, and we basically filmed the video by ourselves. That was fun. And a nice thing was that I was the person who passed through the players. So I was the unexpected object there. Yeah.
But later on, you didn't continue in this type of research. So you went into the direction of reading. Am I right?
Basically, yes, for my second master in neuroscience. But before that, I did a conversion course. I did a master in psychology, again, with the same university as in my bachelor. And unfortunately, it was when COVID started. So we faced a lot of difficulties back then with the research, but we managed and we did a research with real people because a lot of my fellow students did like literature review back then. It was easier. But yeah, I did this master. I basically continued my research from my bachelor, but with adults this time. And we also wanted to see if there is a correlation with working memory capacity with that phenomenon of inattentional blindness. So we used a working memory task then, which was interesting, but we didn't find any correlation back then. So,
And how would the classical working, or what type of working memory setup did you use, just so we can also understand what you did there?
Yeah. So it was a knee back task. So basically, we wanted to see if a person can remember a couple of letters that are passing through the screen in front of him. So every time you see like A, B, C separately, and you have to recall if the letter that you see every time has been introduced before. That can differ. It can differ based on the position of the letter. If the letter that you see was introduced like 2 letters before or 3, and then you build up the cognitive load of the task. So you see if you can change that, and if that is correlated to attention or something. Yeah, you can do a lot of things. Yeah.
Okay, and what did you do afterwards?
Yes. So afterwards, I made the decision to go abroad, and I was accepted in the University of Maastricht in the Cognitive Neuroscience Master. It was really a very, very nice experience for me, and I became very fascinated and decided to change a bit my research topic because I wanted to discover more. So for my internship and my thesis, I collaborated with the Maastricht Brain Imaging Center and the language group there. And given my previous interest in learning, the aim of my thesis was to investigate the type of reading display on later recall of text elements. And we designed a study to investigate the effects of congruency of text and graphical content on reading behavior and on later recall performance. Yeah. Which was really interesting. We tested fluent English adult readers to read little stories at their own pace. So it was a natural reading experiment. And while we basically monitored their eye movement via an eye tracking monitor, which was also very, very hard to do, I would say. Yeah.
So am I getting that right, that natural reading refers to people read in their natural pace of reading? And because I know that in some setups you present, for example, words individually and then try to construct in how far they or the readers understood. But in this setup, they were just presented with a text and could just read as they would read normally.
Yes, exactly. So we didn't have like a timer or something and we said, you have to read this in 2 minutes, in 3 minutes. No, it was at their own pace. And basically after that, after each text, they had to answer some multiple choice questions based on the information they read. So we measured also the working memory capacity there.
And you've also mentioned that you combined the texts with images, right?
Yes. So the text was a little biography of a person, of a famous person. And we had 3 conditions, which basically are correlated with the pictures that we presented. So the congruent condition was the condition that the picture was actually the person that the text is referring to. The incongruent condition was a person that is like a different gender we use there. Like if the text was for a female person, we used a male person for the text. And we also had the control condition, which was a scrambled picture. It didn't present a face. Yeah.
So I think you've sent us a poster before, and I was just also wondering in how far general world knowledge or general knowledge plays a role, because if when you read a text about a person, you might not know how this person looks like, but when you explicitly use a different gender, it makes it easier to not only rely on the information itself, but actually to kind of trust on a certain world model people might have or not have, right?
Yeah, true. And it's really interesting because I wanted to see also how familiar the person was with the stories that they read, with the people that they saw, because they were like really famous people, like singers, actors that we see. So after the experiment, we had a familiarity scale in which they had to select how familiar they are with a person, and they were very familiar with all the people that they saw, which was interesting because in the results we saw something really, really interesting about how conditions differed with one another. So it was really interesting because during reading, the eye movements can go from text to picture and from picture to text. So there is a pattern sometimes on how we can see what a person sees and where the attention is. So we basically are interested in fixations, and let me give you more content there. So a fixation is when a person like fixates and focuses on something. So to measure these conditions, we wanted to see how the fixations among the text and among the pictures are correlated with each other. So we assumed that the longer fixation duration, the counts and the percent in the text area can indicate a greater cognitive processing. So basically, we wanted to see if this elongate fixation time and count can have an effect on how people read and they interact with the material. Yeah.
And how far do you mean interact?
In terms of how much attention they put on to something. So basically it was interesting because during the reading, eye movement data in text and picture area in the first part of the reading process, because we usually try to discriminate the parts, like the first time that they look the text, the second time they look the picture, and etc., etc. So in the first run, we saw that it was a reduced fixation duration count and percent in the picture. And that was very contradicting with the scrambled condition. We saw that in the scrambled condition, because it was something that they didn't know what it is in the picture, it was something like very, very blurry and gray and white and black. They tried to put some meaning on that, and they fixated a lot there. It was
So,
interesting.
so kind of when the people you presented were familiar, they just focused less and shorter times on the person and more on the text. But when the image was nothing really displaying, they kind of tried to figure out what they might see in
Yeah.
that picture.
Yeah, exactly. Which makes sense as well, because they want to see if there is a clue there, or if there is a hidden person, But yeah, it was interesting. Yeah.
And kind of you just mentioned that there was a back and forth between text and image, right?
Yeah.
So kind of did you measure in how far or how long a person focused on the text, then on the image, then on the text, and then on the image again? Or what did you look at there?
So we tried to see the sequence, if they started first at the text or at the picture. Most of the times it was the text, and then they looked at the picture, which is also insane.
Yeah, I was
Because
just thinking, my intuition would have been first look at the image and then start reading.
yeah, that was really interesting, because we expected that the first gaze would be on the picture, because it's a face. It's not something like a tree. It's not an object. Faces are very strong images for us. So no, that was really interesting. They started reading immediately, and then when they realized, oh, okay, I'm reading about this person, then they went to that image. Yeah.
So they switched like within reading, so they didn't complete like the text, completed reading it and then switched to watching it, but like took like at one sentence or something, and after
Yeah.
that they then compared it to the picture.
Yeah. They switched a lot. Like they went back and forth between the picture and the text. Yeah.
And kind of just a curiosity question, do people tend to read a whole sentence to the dot, or do they tend to split sentences when they look back and forth?
We didn't look that, but from literature, I would say that it depends on the context and on, the difficulty of the text. We saw a lot of rereads in my case. So I assume that they might not finish. They went back to see if they missed something, but that depends. Yeah.
The whole setup reminds me of these like novels for kids or something that just started to learn reading, and then like every noun or something is like replaced by a small image or something. And I'm now thinking if that's like a great developmental tool, and if like having read something like that as a kid like primes you for the task somehow.
Yeah. Actually, the aim of the study was to see if, because usually we know that in textbooks, the texts are frequently combined with graphical information. So, do we see that this is really helpful for children or not? In this case, we did this research with adults, but I want to continue this with children, because I know that at the end of the day, I don't think that pictures really help sometimes. It depends. They can be very destructive sometimes. Yeah.
It's just, I think the case Sönke just mentioned is really specific because there you have the words being, or the sentences being disrupted by images. But I
Yeah.
was just also wondering how it is when you have the classical children's book with images, because there normally you have a text, a bit of text, and then an image. And I was just wondering if there's any research you're aware of in how far comprehension, maybe in adults or kids, of purely text-based or text combined with images is different to any degree.
There are a lot of examples with dyslexic students, because there it's a bit tricky. And we tend to believe that, okay, if I just show one word, the child will read it and will remember it. And With dyslexia, it's not like that. And we usually tend to combine the word with the image there, because we have to give them something else to hang on and remember. And an image is a very striking thing to see. And especially if it's additive or related to the thing that we read, it can help us memorize more or understand more. Yeah. But I'm not sure if there is a final result on that, if text alone helps us better, if images alone helps us better. Usually it's a combination that works the best, but that depends on the difficulty of the task or on the information that we read. In my case, in the study that I did, the pictures were additive to the text. And I was thinking about how we could do things differently, because if I wanted to see if they really understood or if they really wanted to see more information on the text, I might have added like objects in the images, like next to the person. If in the text it says that, oh, okay, that person plays piano, I could have put a piano next to the person, just, tiny details to make sure that I give also some information from the text to the picture.
I think, just mentioned the term additive, and I was thinking, I think the example I thought about most was, for example, in textbooks in school or biology, especially when you have all the images to explain what is happening in the body. And that's, of course, a different issue, because there the image itself explains what is happening or what is being explained in the text as well.
Yeah.
While, for example, when you read something about a historical person and you see an image, it might just be maybe, I don't know if it's easier to remember who that person is when you have a face.
Yeah.
But I feel like the person gets more graspable for you if you have an image. So
yeah.
I think for the comprehension, it doesn't make a difference, but just maybe for the memorizing, right?
For the memorizing, it makes a difference, yes. And I saw that also in my research, because after the participants that they had to answer the questions, they answered very good. They didn't had more difficulty when the image was incongruent to the text, which was very interesting. And I saw that, yeah.
You just said that when the imaging was not matching to the text, they did not have more difficulty compared to the other group, right?
Yeah.
Okay.
Yeah. Which was interesting, because it was my hypothesis that the incongruent image would mess around there, and they basically could not answer the multiple choice questions correct. But for some reason, and probably because they, they tried to stay focused on the text, that's why we saw more fixations on the incongruent condition to the text than in the congruent. They did well afterwards. It didn't mess up their memory performance after. Yeah.
Is there an effect, or have you checked for an effect to the control group? Because I'm now making up hypothesis in my head that maybe that the fact that the face was different is especially then heightened their memory for the actual information, because they try to distinguish in their head what's the difference. But then that would mean that in the control condition where there's no face, then they would have cared less or paid less attention to the details of the person, and therefore perform worse in the multiple choice.
So basically in the control condition, we saw that they fixated at the picture, which was not a person there. They tried to give meaning there, but they also had a lot of fixations on the text, which means that it was a distraction there. We didn't get something from that, so let's go back to the text and start reading. But they spent a lot of time trying to find the meaning there. So probably they also fixated more to the text after, because they wanted to keep up with the information and, build up a bit. Yeah.
I was just wondering, did you compare and how far the reading time differed between distracting or incongruent, congruent, and control group? So was there a difference between how long people took to read?
Yeah. We expected that at least in the incongruent condition would take longer, but it was the same across conditions. It was the same.
Interesting, yeah.
Yeah, very, very interesting. Yeah. I don't know. For me, I think those different levels of congruency can trigger like different reading behaviors, because they try to also see the load differences while they read the text. They try to see, okay, is this easy? Is this difficult? If it's difficult, I'm gonna do it. I am gonna read it. That's how I interpret this, that they stick to their plan to read the text. Yeah.
So it seems like attention plays quite a role in that, because they kind of have to make a decision on paying attention to the text rather than being distracted by the wrong image.
Yeah, exactly. Exactly. Yeah.
I was just wondering, when it comes to attention, it's always like, for example, in the example we had at the beginning with the gorilla, it was paying attention to a certain thing and not paying attention to a different thing. Could that also happen in a reading task? So like when people get that distracted by the image, maybe they stop paying attention to the text, forget about the actual task, I don't know. And how could you kind of forcefully trigger that, or how would you maybe do that in the setup?
Yeah, so nice point, because when I first tried to structure the study, I wanted to do something similar with the inattentional blindness study that I did before with a distraction. And I thought of a picture that is not matching the text. But I think with reading is a bit different, because I don't know, for people that they want to stay focused on a task that is about reading, it's completely different if I tell you to count passes or count cars. It's a completely different task. So at the beginning, I wanted to relate those things, the inattentional blindness and the distractive picture, but I think it's something completely different from one another, because the distraction comes and goes. It's for a moment in the inattentional blindness phenomenon. The picture was there the entire time. It wasn't something that happened very quickly or once and it disappeared. So I think at some point the participant realized it. In the inattentional blindness, you don't even realize it. You don't see it. There were like questions after the video that the participants like said, "Oh, there was a gorilla there. I didn't even see it. You're lying to me." They didn't even see it. But with the reading task and the distraction with the picture, I think it's completely different, because you have the time there to process it and see it. Yeah.
And I was just thinking why you explained that you could also do kind of read the text first and then present a picture really shortly, and this picture could either contain correct or incorrect or congruent or incongruent information to the text, and then measuring how far this confuses people because they can't reread again. But that again would be a different setup compared, or would measure something different compared to the blindness.
Yeah. But that, I mean, I was thinking of that, like presenting something or like a red dot at some point, and then after the experiment ask them, did you notice that? And that would be more like with the inattentional blindness phenomenon, which is really interesting. Yeah, I'm thinking of it, of my next steps. Yeah, definitely. Yeah.
I'm still thinking about like the term attentional blindness, because like being blind is kind of the opposite of seeing something.
Yeah.
But then for like the paradigm, I'm thinking like, is there the opposite of attention? Because I would assume that it's distraction, but then again, it's just like only within the paradigm of a certain thing. So like you are paying attention to the text and then you are distracted by the image, but like from the perspective of the person, you still attend something. So instead of attending the text, you then attend the image. So is there something for a human that is like not attending something, or is that just like in terms of a subject of your attention that you can be
Mm.
inattentive?
Mm. I think it can work both ways. I mean, for sure, we have limited capacities from our visual system, because we are talking about visual attention right now. So I think it's really interesting how we might think that we are very ready to process everything that we see, but at the same time, we miss a lot of things. But with inattentional blindness, it's really interesting, because basically it shows how slow we are, or if we put our attention on something like very vividly, we miss a lot of things. And that can be good sometimes, but usually it can be dangerous, because if we imagine like in a real world setting, if we want to pass the road and we look left or right to see if a car is coming, and we are talking on our phone, or we read a text message at the same time, we might not see the car because of that phenomenon, because our brain is structured like that and cannot handle a lot of information when we are really focusing on something. Yeah.
You've mentioned at the beginning that you were really interested in child's research or research with children at the beginning,
Yeah.
and also think about going to that direction again, if I'm not much mistaken. So,
Mm-hmm, mm-hmm.
And we've talked about and how far text-image combinations might influence how children learn. And I think the
Yeah.
most prominent place where children learn is at school,
Yeah.
where they get pretty much similar books for years, where they have kind of text plus images. Does that
Unfortunately,
help? Does that
yes.
not help?
Yeah. Unfortunately, yes. So it's really interesting because we have all this knowledge through research that it says that in some cases pictures help, in some other cases they don't. It depends on the context and depends on what you want to teach. But since we have all this knowledge, we don't use it to make things better, because I see a lot of children that they struggle at school, especially reading from textbooks, because they don't know how to focus. They don't know how to put their attention on the things that they read, and that's really bad. And I think it's not the child that has the problem; it's the book that it's not structured correctly for them.
What does the
Um,
research tell us about how books should be structured to support children in understanding and reading and focusing their attention on
yeah,
something?
yeah. Usually, most of the research says that it's good to use a lot of things, not only the book. So, if you want to read, because that is also correlated with phonemic awareness, you have to cultivate also other things before you go to reading. You have to be able, as a teacher, to make sure that you have a lot of material, like vision boards, or like songs, use of sounds a lot. It helps. And I'm talking about the first grades, of course, because later on, if you are really good and you can read easily, then you can cultivate that and be in a good level. But when you first learn to read, the teachers must be very, very aware of the phonemic awareness. And usually, and I don't really agree with that, this starts from kindergarten. Like 4 and 5-year-old children, they try to read, and this is wrong. This is a wrong age to learn to read. It's very early because they don't have clear phonemic awareness then, and they cultivate that. Yeah. At least in Greece, the educational system here.
Yeah, I think in Germany, kids usually learn reading in school when they're 6.
Yeah.
On average, I think that's the most average age.
Yeah.
And I think at least in Germany, in my school, we kind of learned the sign alphabet.
Yeah.
And also kind of, but it was more like reading letter by letter and having those, I don't know the English term, whatever, Lesefieber, Sönke, do you know how to translate that?
Okay. I have no idea.
Also cannot help you. I don't know German. But
yeah, no, it's totally fine.
Yeah, but it's really interesting because it's really important to say that the human brain is not structured for reading. We don't have a region in our brain that says reading region. We don't. We are not structured to read. So in order to translate letters and to make sense, we use our brain and basically we use different areas like visual processing, language comprehension, speech production. All those areas are combined when we read, and people do not know that. It's really interesting.
Yeah. But it makes sense because letters themselves are quite abstract. They don't, like there's no connection between how a word looks and how it sounds. Of course, there are patterns and you learn the patterns, but when you first learn reading, you don't know why an A should sound like an A or why a B should sound like a B.
Exactly. Exactly.
And it's kind of learning a new language, which you are in the end. You still speak the same language grammar-wise, but you learn how this language looks like on paper.
Yes, and we are very fortunate because we use the alphabet, and we can basically, you learn all those letters, how they sound and how you can write them, you can basically produce words, which is the opposite, I think, in China, because in China, letter, I think they don't use letters, they use whole pictures when they write. So one symbol is a whole sentence, I think, or a whole word sometimes, which is interesting because the learning there is very hard. I think they have to learn all those symbols, and this symbol is sun, this symbol is moon. At least that's what I've heard. I don't know Chinese, but yeah. That's why in China they don't have dyslexia, or it's
really?
not very common. Yes.
Because they have to learn the images, or
yes, they have to learn. They learn by images. They don't learn by letters. Usually you see in dyslexia, a very common example is that children, they cannot recognize B and D, the lowercase letters, because they look alike a lot. But in China, because they don't use letters and they use images, they don't have those confusions. So the dyslexic population, I think it's very low in China compared to other countries.
This kind of brings me back to, well, especially children's books, because there are those children's books where parent, if you have a preschool or pre-reading aged child, where the parent has to read aloud the story, and then you have those books where you only have images without any text. And normally in children's books, the images match the text, so guess it stays interesting. But I was just wondering in how far it might be, or in how far that's maybe you're aware of research on if it's beneficial to have just image-based things for younger children rather than word-based stories, because I guess just image-based leaves more space for exploration, for creativity, etc.
You can, I think, for at least if we are talking about kindergarten children, in which we know that there are cards that you sew like a sun, and beneath it's the word sun. That is good, but not good at the same time, because there is no connection between the image and the text. Because the text at that age, it's also an image. So there is no point there. A nice thing to do is to combine those two together and basically try to put the letter in the picture or draw it in the picture. If we use our imagination a bit, that can make more sense, I think, for the child.
I was just thinking, because when I learned numbers, writing numbers, we also had images for that. For example, I still remember the 2 was a swan-like shape. So we had in my primary school class, in year 1, we had like posters of all the numbers, and each number had kind of a image attached to it. And for me, the number 2 still is connected to swans, because I just learned by how to write the number. And I was just thinking, I think I saw similar things for letters as well. But then it's usually connected to a word that starts with a letter and not with a word that looks like the letter.
Yeah. Sure, there are a lot of techniques. It helps if you use a lot of material. So before you go to pen or pencil, you usually try to use more soft materials like sand, and the child can draw the letter on the sand. So that gives them a whole different perspective of the letter, because they use their body to make it. Or clay, a lot of clay, or Play-Doh. They use a lot of those things, which makes it easier. Because I worked as a kindergarten teacher like for 2 years, and for the toddlers, we at least try to make them to write their name, just their name, and at their own pace when they are ready, because those things can differ from child to child. And we use a lot of games for that, and that makes it easier for the child to understand the letter, that okay, this is a letter, it's not an image anymore. And we use a lot of phonemes to distinguish its letter from the word. This is really important, and that is related to reading after, because it's about the phonemic awareness and builds up their reading comprehension afterwards. So it's really important to work with that from that age. Yeah.
I'm again thinking of the Chinese writing example, because I was now wondering in how far the results might differ between languages that are letter-based and languages that are image-based when they are written as well, because I was wondering how far also the focusing might differ between those types of languages, because if you already have images in your words, I don't know, do you know if that differs with how to focus on
Yes,
pictures
also
themselves?
basically your brain works a lot different, I would say, I would assume. I don't know if I don't know any research, but I think that there is a whole different organization in the brain of how you process those things, because for them a picture, it's a word, so which is also very hard to learn. I think the alphabet it's something that at least you can build up with that. But when you have pictures for words, you have to learn every picture, which is a million, I don't know, a lot.
Yeah.
It's way more difficult. Yeah.
I mean, since we can see that you are still very passionate about like educating young children, is that something that you still want to do in the future? Is this where you are moving towards right now, or what are you like planning to do with the results or your research background in the future in that regard?
Definitely, I want to continue with a PhD, and I'm interested in educational neuroscience, which is a very new field. And recently, I was in a conference in Leuven with IMPES, the International Mind, Brain, and Education Society. And basically, there I saw that researchers, that they are neuroscientists, they go inside the classrooms and they do EEG experiments in the classrooms outside the lab, which is amazing. And basically, it's very interesting because we can see in real scenarios, in a real classroom, what is happening in the brain. Of course, we have a lot of issues in that. And unfortunately, right now, they haven't extracted an ERP yet. They only looked like oscillations, and I think they were mostly interested in alpha waves. And I think one research was about how do we measure attention in the classroom. And their hypothesis was that the more alpha, the less visual attention was.
Can you maybe explain what alpha is? And you also mentioned ERP.
Yeah.
Can you maybe just briefly say what those terms
Okay. Yeah. So an alpha wave can be observed during a relaxed state, especially when there is no mental activity. So there is a very famous experiment with eyes open and eyes closed condition. So the alpha wave is expected in the eyes closed condition. And they are very, I think, prominent at parietal locations at the brain, if I remember correct. Yes, so I think in the experiment that I mentioned before, they wanted to see if a child gets a bit tired or doesn't pay attention. They want to see if there is a change there in the alpha wave. Yeah.
and ERPs are event-related potentials.
Yes.
So they, I assume they wouldn't like to see in how far, for example, new information changes the brain activity,
Yes.
or is it different?
Unfortunately, for the ERP, they didn't provide a lot of information, but as we know, it's transient fluctuation in the brain's electrical field generated by neural activity. At least for reading, we know that the component N400 is very prominent there to make meaning and for comprehension.
I think it's especially present when meaning is not congruent, right?
Yes, I think so. Yeah, I think so too. Yeah.
Okay. I'm just still fascinated by the fact that researchers are starting to go into classrooms to measure. It makes sense. It makes totally sense. But
it was about time, I would say, because we tend to measure things like reading, attention in the labs, which is completely wrong. I mean, completely, I don't know, but at least you don't measure them in their full potential, I would say. It's really interesting, yeah.
How difficult is it to control for noise? Because I know that EEG data collection is super tricky. You are not allowed to move, you're not allowed to chew, you're not allowed to blink too often. So you should really sit still. And does that work in a classroom?
Yeah. So I am basically what what they did was that they had a research lab close to the classroom. Because, of course, as we know, like you have to be very focused and very relaxed, and you don't have to move a lot because you have a lot of noise in your data afterwards. They try to find ways to make it better. It's a challenge. It's something that I want to do for my PhD as well, because also we are talking about mobile EEG. It's not. I think they connected with Bluetooth with a PC, but it still has to get better, I think. But it's a nice topic. Yeah.
Might have nears, so like using using functional near infrared spectros. I had that word. Does functional near infrared spectroscopy, would that be a solution? Because as far as I'm aware, it's not as sensitive to noise, especially movement related noise.
Yeah, I think that's a nice idea. But I have no clue about it. I don't know. I'm really interested to dig more when I do my PhD. Yeah.
Since this started as a cognitive science project, but we also try to broaden our guests so we don't require a background in cognitive science, but we still are interested in the thing that is very central to it, so cognition. Do you have any idea, or do you have an intuition what cognition is and how it is, or how it relates to the research you are doing?
I mean, I know that cognition is about how we learn. Basically, that's the basic concept of that. But I tend to think one step further, and I would have imagined that cognition, in my case, and as I think of it as a scientist, is also what we can do with that knowledge. It's not only how we acquire it, but also with how we can do it. I like the term metacognition better, and I try to focus there more, because cognition is one part, but metacognition is another one that I'm really fascinated by, and I want to discover more.
Thanks. When a person has listened to this episode, is there something they should remember in 2 weeks? So what would be something to definitely remember about attention and reading?
I would say that a nice thing to do is to read for yourself. And I know that this sounds like very philosophically and very romantic, but attention has to do on how we perceive ourselves and how we want to achieve our goals. So I would say that your attention would be better if you read for yourself and not for someone else. So try to focus on yourself and on your goals. Yeah.
Thank you so much. Also, thank you for taking the time and talking to us, and for all the lively discussion we had. I really enjoyed it.
Yeah, I really enjoyed it too. Thank you.
You've listened to Science, Conversations on Cognitive Science, hosted by Elisa Palme, Sönke Lülf, and Sophie Kühne. Produced by Clara Kühne, Imogen Hüsing, Elisa Palme, Leslie Wolk, Sönke Lülf, and Sophie Kühne. Produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science. This podcast is not sponsored and does not give us any financial profit. If you wish to support us, the most effective way is to do so by leaving us an up to 5-star review on your chosen podcast platform and following us on Instagram. You can reach out to us via mail, comment on YouTube, or message us on Instagram. We are always happy to hear your feedback. Thank you again for listening to us and for your interest in science. If you have any questions regarding this episode or any of our other episodes, feel free to reach out. You can reach out to us via Instagram by sending us a direct message at kaleidoscience_pod or write us an email at kaleidopod@us.de. You can find both links to our Instagram and also the email address in our show notes. We do read all your comments and will also reply to you as soon as we can.